complexity and we'll study later. Now I'll go into the problem. Topological sort. This is one kind of sort which we do, how the sorting is happening from the particular graph, how you are going to sort it. So here we are going to follow the queue method only, we are going to follow it here, and you cannot do topological sort if there is a cycle. Not possible if there is it should not be a cycle. The cycle should not be there. So I'll tell you the procedure. Please listen very carefully. Find the integrity of every vertex. Your step is, first you have to find the integrity of every vertex. Then what you have to do is, once you have found the integrity, you have to find whose integrity is 0. Someone's integrity will be 0. If any one of the integrity is 0, you have to place the vertex in the queue. You have to put it into the queue. So you put the particular vertex which is having 0 into the queue, and from the graph or from the, either from the graph or from the matrix, how to find from the matrix whether there is, how to find the adjacent vertex from the matrix. How to find the adjacent vertex from the, maybe from the graph you will be finding, okay, V1, there is relation to V2. Adjacency vertex means V1 has connection with V2, V1 has connection with V3 also. So V3 and V2 both are adjacent. Okay, but V4 is not adjacent because there is no. But if this is not given, only this graph is, matrix is given, how will you find the adjacent vertices?
0 if it's
0.
ma'am, if you have 0 value over there.
No, 0 is there means then it is
If we
not
have 1,
adjacent. No, 1. If it is 1 means it is adjacent vertex. So in for V1, V2 and V3 are adjacent. For V2 only V4 is adjacent. For V3, V2 is adjacent. For V4, V3 is adjacent. If you look into this, now you will find out. Whatever in out degree only will be mostly will be the adjacent matrix. Out degree only will be the adjacent matrix. Okay. In degrees will not be the adjacent matrix. Out degree will be the adjacent matrix. Keep that in mind. So if I give a graph, you can find the out degree. Out degree is useful for finding the adjacent matrices. Okay. So now keep it in mind. If this is not given, only the matrix is given means which all are marked as 1 only will be the adjacent corresponding adjacent matrix. So now I'll come to the problem. So now first step is finding the integrity. Find the integrity for all the vertex. Then take the vertices whose integrity is 0. Okay, and put it in the queue. Once you put it in the queue, the main thing, that is on the empty queue. In the empty queue you are putting, you are placing it in the queue or inserting it in the queue. Then after that, once you insert, immediately you have to dequeue also. When you dequeue, you have to find the adjacent vertices and decrement the value of the adjacent matrix. So I will tell you now is the problem itself. Then I'll tell you the steps. Now see here. For A, B, C, D, first step. Look into this first step alone. Don't see this. Look it in the first step. For A, what is the integrity of A? What is the integrity of A?
0.
0. Okay, then 0.
0.
What is the integrity of B? First step is find the integrity
1.
of, if they give a graph like this, first step you put a table like this, and table should contain NQ, DQ, everything. So this initially, this all nothing, everything will be plain over here. First step, I'll write the first step, A, B, C, D. So what I will do is, I'll first find the integrity of all. So I'll put integrity of A 0, integrity of B
1.
integrity of B 1, integrity of C
2.
2, integrity of D
2.
2. Okay. So in my first step, I will calculate all the integers first. Okay. From the graph, I have taken the integrity. And now what I will, or else if they give a matrix, what you do is convert the matrix into the graph, and find the in degrees. That is the incomings. In degree means incoming. Okay, that means from the matrix it will be very difficult to find the in degree. Out degree means it will be 1, it is okay. In degree you have to do it very carefully. Instead, draw the diagram. Diagram from the matrix, and then you can proceed. It will be very easy for you. So find the in degree. Now in this 4 values, concentrate on only this area. In this 4 values, whose in degree is 0?
A.
A. Okay, A is in degree 0. So what I will do is I will push inside the Q. A I will push inside the Q. Okay, A I will push first inside the Q. Next step. Next step. So I have done the first step. I have found the in degrees. Then I have found whose in degree is calculated all the in degree first step. Then second step, what I am doing is I have pushed the A inside the Q now. Whose in degree is 0, you have to push inside the Q. Maybe if A is not 0 means, then if C is containing 0, then C only will come first. Because now in this diagram it is coming in order, but it is not the fact that it should come in order. For example, if A is not having 0 and B is only having 0 means B only will be pushed into the Q first. Clear? Okay. So now I have calculated whose in degree is 0, that I have pushed it into the Q. So now I have picked it now. A is inside the Q. After pushing the A inside the Q, my next step is immediately I will DQ it. DQ it means I will cancel this and I will put it in the DQ. So when I am putting it in the DQ, I have to find the adjacent vertices. What are the adjacent vertices of A?
B and
Adjacent
C.
vertices of B and C. B and C are the adjacent vertices. So what I will do is, I will go to the step 1. Adjacent vertex of B and C alone, I will decrement by 1. So this will reflect the same. And adjacent vertex of B is 1, that I will decrement to 1 minus 1. So it becomes 0. This is decrementing to, so I will put minus 1 for B as well as minus 1 for C, adjacent vertex. 1 minus 1, 0. 2 minus 1, it is 1. And D is not the adjacent vertex of A, so just I will reflect the same value. I'll repeat it once again. Step 1 is completed. A, I am DQing it, NQing it first. Then when I DQ alone, what I am NQ, that only I can DQ. So A is now in the DQ part. When I am DQing, I have to remind one step, which is I'll find the adjacent vertex of B and C, and that in degree alone I will minus it, minus by 1. So 0, A is 0, same thing you reflect. B I will minus by 1, C I will minus by 1, and D is not the adjacent, so I will reflect the same value. Clear now? Clear? Okay. So now step 2, I will come to step 2 now. Step 2 when I take, now see, look, whose in degree is 0 now in step 2? A as well as B, but A is already visited. So I will not take A. Which one I will DQ next?
B.
NQ. B. B is only holding 0.
B.
So I will push B inside the Q. After pushing B inside the Q, I will immediately DQ the B also. I will DQ the B. When I DQ, what step did I ask you to follow? Someone tell me what step should I follow when I DQ B?
Minus 1 from the adjacent neighbors.
Yes, correct. So what are the adjacent vertex of B?
C and
Adjacent
D.
vertex of B is C and D. Yes, C and D. So I will now reduce my value or minus 1 C and D is in degree. So remaining I will put as such and minus 1 for this, minus 1 for C and minus 1 for D. So it just becomes 0 and 1. Okay. So now my next step, what should I take? Next in degree is falling on 0.
C.
See, in this diagram it is coming in order, but actually it does not happen. Any order, whichever order, if 0 is, whoever is holding 0, that only will be pushed into the Q. So here it is 0, so I am pushing inside the QC. and immediately after I push, I will decube it. Okay, decube. So now I have done this. Now what I will do is, I will, once I decube it, I will find the adjacent matrix of C. So C is adjacent is D only. So now what I will do is, I will minus 1 D, and that has become 0. Now that I will include as well as declude. Now all of the
Ma'am,
yeah.
um, just assume that from B to C there is no edge,
Hmm.
and the edge is from D to C.
Okay, D to C. Okay.
Yes, ma'am. So all the in degrees will be the same only.
No, no, no. You are telling that this is not there, right? And you have from,
No,
do you
as
have
C
here?
to D and D to C both are there.
You are assuming that both are there. Hmm.
Yes, ma'am. So and the B to C edge is not there. So in that case, when after we have NQ'd and DQ'd B,
Hmm. Hmm.
so the B only has one neighbor D. So
Hmm.
only D will be subtracted. So for
Yes,
C and D
yes.
in step 3, both one will be left.
See, that means it forms, see, when your topological sort is not ending and it is keeping on moving, you have to calculate until it becomes 0, or else it forms a cycle. I think you this will form a cycle, I think so. The arrow mark which you have told.
Yes, ma'am. C and D will get stuck at 1 at step 3.
Okay, step 3, C and D. Okay, you are telling that here there will be a 1, and here also there will be a
And
1, you are telling, right?
yes, ma'am.
Okay,
Yes, ma'am.
C and D, if
So
it
now
is
what
1,
we'll do?
what you have NQ'd now?
Previously we had just enqueued B already we have done, and there is no 0. So what? There's nothing we can enqueue, right?
Yes, yes, here in this step you cannot NQ. So what you have to do, once again, if there is nothing, if it is not changing to 0, if your integer is not changing to 0, then this graph topological sort cannot be performed for this graph. Okay, you have to,
Okay, ma'am.
otherwise
Yes,
next
ma'am.
step you have to find whether the adjacent whichever you are bringing it to, because in this step already A and B is enqueued and dequeued, and only you are getting A and B. But
Ma'am,
C
what
is
is the
also not
Yes,
point
ma'am.
of
getting to 0 and D is also not getting to 0 means you cannot take, only if the integer falls to 0, that only can be, according to topological sort, if the integer falls to 0 only, you can push it inside the queue itself. Understood? If it is struck like this, then topological sort is not, cannot be performed. Okay? Okay, any other doubts?
ma'am? What is the point of enqueuing and dequeuing here?
This is just, see, enqueuing, dequeuing is to find out the order, how the sorting happens. Okay?
Ma'am, how we will
How,
find that?
what ma?
How we will find that?
You
Like,
will see each time which one is NQing here, A, B, C, which one is NQing and which is DQing. So here in this diagram, your order is A, B, C, D is the answer. Okay? A, B, C, D is the sorting order. Just in case, assume that,
ma'am, if in a case two are zeros,
hmm,
like A and B both are
take it
zeros,
any order. Take it in anything you can
any
take.
order.
Any order. Okay, but normally we follow the alphabetical order, right? That is one. See, in this case, you are getting us A, B, C, D. For example, I give you some other thing. Maybe this is 2, this is 2, and this is 1. For example, I'm telling. Okay, so this will be 1 in the step, and this will be 0. Okay, so in this case, C only will be enqueued, and C only will be dequeued also. Now after that again, if you, that is, this is done now. After that again it will come over here in this step. I think I have done that. Correct? Yes.
Ma'am, but ma'am,
C
we are
only has D
enqueuing
as an
and
adjacent
dequeuing here,
neighbor.
right?
Huh?
Ma'am, here we are enqueuing and dequeuing, right?
Hmm.
Uh, Almost like first we are enqueuing, and right after enqueuing we are
Enqueuing,
dequeuing.
what is in the queue only it will come out, right?
Yeah.
So this and
So
this
ma'am,
should be same. And until your queue is empty, you will be taking out and printing it. That is the meaning. So that is a
so ma'am,
printed order.
what is the why we are enqueuing it? Why we are not printing it directly? It is same
Oh,
if we
that no, no.
enqueue and
Actually,
dequeue
the
and if we
concept which
print.
is okay, okay, understood. Actually, the concept of this topological sorting is queue concept only is involved here. The concept of topological sorting itself, you have to push inside the queue. Then only when you take the or when you call the NQ only, you can actually decrement the adjacent vertex of BN, that is adjacent vertices. For that purpose, enqueuing and dequeuing is needed. Directly, if you print, you can directly what you will do, you will take here if the in degree is 0, if the in degree is 0, you will print A. Then you will be finding the in degree and you will print B. But when you print it, what is the meaning of it is just here for printing. For program, for coding wise, you are telling that you can make it easy. But the thing is, concept wise, topological sorting involves queue concept. Q concept means when a particular matrix is degree is falling, if the degree is equal to 0, you have to push inside the queue. And when you are calling the queue up, that is when you are dequeuing it, that is your first one will be only dequeuing. When you are dequeuing, the adjacent matrix has to be decremented. In degree has to be decremented. This is the procedure or algorithmic itself, algorithm followed in topological sorting. So it is must, maybe for manual calculation or for simplification, we can tell that it is easy to take it out and print. But as per your algorithmic concept, there should be the step of enqueuing and dequeuing. Okay, only when you dequeue it, you will be decrementing the vertex. So in this graph, A, B, C, D is the answer. But there might be answers like A, C, D, B, or ACBD based upon the in degree or based upon the graph. Or even A might not be 0 and it might be anything C0 means you will get the sorting like this also. All the answers are right based upon the graph and telling. Okay, it is not the thing everything will be in order. In this graph alone it is in order, that's all. But the order can be anything. So finally you are going to sort it and find out, maybe they will give numbers also here. So don't think you will be getting the numbers as 1, 2, 3, 4, 5 exactly as the sorting. It's not that many. It's how the particular based upon the in degree and out degree only we do this topological sort alone. Okay. So NQ and DQ is needed for finding the adjacent matrices to do the next step of each step of calculations. Okay. So that is what given here. Repeat all the steps. And this is normally you will be having a counter. Why we are giving the counter is whenever you are dequeuing, you will be incrementing the counter. This counter is, if you are why we are doing this counter is if your counter and the number of the vertices are not same, that means see here A, B, C, D all has been dequeued or enqueued. So what happens? Your enqueuing or dequeuing part, that is the counter. Each time when you dequeue it, you are counting. Your counting and your vertex, 4 vertices are same. So counter also is 4, vertices also 4. That means my graph is right. That is I have received the output. But if your counter is, in case someone asked me, right, if there is if both are 1, in that case there is we cannot move any one to the queue. Because all are 1 and there is no zeros. So if there are no zeros, nothing can be done over here. So my counter has been incremented to only 2. A and B only pushed, but C and D not pushed in. So in that case, 2 not equal to 4. My counter and this is not 4. That means your graph has a cycle and you can dispose the queue. Okay, so this is the meaning. It is not the thing all the time you will get the right answer. If all the in degree are correctly falling to 0, you will be getting in order. For finally, if all the nodes are being visited in the sense all are dequeued, means then only dequeued in the sense what is enqueuing only is getting dequeued. So that's what I'm telling with this term. So that means all the nodes and this dequeuing is same means it is correct. All are, you have a sorting over there. But if your dequeuing is only, there are some multiple 7 nodes are there, but you have dequeued only 4 and remaining 3 you could not do at all, means that means your graph has a cycle. You cannot perform the topological sort in that particular graph. Okay, that is the meaning for your topological sort.
Ma'am, if
Ah.
in one step the in order of two vertices is 0,
Hmm.
then we'll DQ anyone first.
Any one only first. Then in the next step, you have to DQ. Then in the first step, you'll be having, maybe for example, B and C are 0 means, okay, you are DQing B. You're DQing B, that means it is you're NQing B, you're NQing and DQing. Maybe in the third step, you will be having 0 for C also, because in this step, if you have 0 for both, and in this step also you will be having 0 for both, so it will check from the beginning only. This is already done, visited, this is already done. Maybe in this step you have one more 0 over here when you do it, but finally you have to come in order only. C only will be the next DQ. Clear now?
Like here you said maybe B, C, and D all are 0.
Ah.
Then the decrement operation won't be done, right?
No, it will be done. Which one you are doing it here? Yeah, yeah. If all are zeros means okay. Decrement, there is, it won't go to -1, all it won't go. It won't perform. It is the
But
meaning
after
itself, means
every
when it
NQ
becomes
and
0
DQ,
means already visited. That is the meaning.
okay,
Wait
okay.
a minute.
After
Okay.
every NQ and DQ,
Ah,
decrementation will be done, right?
yes, yes. Decrement will be done. But if it is for already visited node, it won't be done. Adjacent vertex, maybe for example, if I'm taking A is 0 first, then when I take B, and I'm intuing, it means only 2 degrees. Okay, C and D. In this diagram it comes, but for example, if I have a line over here, B is also having to A, what happens is don't decrement 0 to -1. Okay, A is already NQ'd. It will check for that option also. It is already NQ'd or already DQ'd. It is already visited. If it is visited means you will not again do anything with
Ma'am,
that. Yeah.
ma'am, just now you drew from B to A, so A also has one in degree, so A will
Hmm.
also be 1, right? So then if none of them are 0, then which one are we going to NQ? Like if
That
none
means
of them are
nothing will
0,
be
like,
done. Now you cannot do the graph as a cycle. If, for
okay,
example, if this is also 1, in this case, if it, in this topological sort itself, basic condition is in degree should be 0. Okay. So for this graph, it is not possible. That is the meaning. You cannot proceed at all. Okay.
yes, ma'am.
Ma'am,
Yeah.
here
Hmm.
if the in value in order for C was also 1,
Hmm.
then what
Okay.
could we have done?
C is also
A
1.
was 0 only, B
A
was
is 0.
was
Okay. Okay. In this case, here 0. Okay. Already I have MQ DQ. Now B will become 0, and this also will become B and C, right? B adjacent is C and D. So this will become 0, right?
yes, ma'am.
And okay, that's all I think so. A adjacent only we are seeing, right? Is becoming 0, 0. Okay. In this case, first one you can take B, go and NQ it. Okay. B you NQ it, and B you DQ it. Then when you DQ B, look into the adjacent matrix. Adjacent is D and C. So it will come over here. So already, okay, what it will do, this is copied as such. This is copied as such. And here it is already 0. So that will be copied as such. It will not go to -1. Now this will be decremented to 1. Now again it will check whose in degree is not at all visited. This both are visited. This is only not visited, right? So it will take C next.